So last week's exercise was about matplotlib, pandas, and numpy. So we'll tackle it so quickly. So on the first one, it was about the data visualization with matplotlib. So the first question was plot a line graph showing the total revenue per month. So you'll just open your Google Colab. Okay. Then you just head to the folder section. Then let's import the file, the CSV file. Let's give it some few seconds that it loads. Load. We'll just import the company data file and import all the libraries. First import others also PT. Oops, sorry. Just check read the file. Read read CSV and take this file path. Go to the head section. Yeah, it's good. It's good. So we'll start with the first question, which was plot a line graph using the total revenue per month. Okay. Here, so importing the pipeline, so we'll create data frames. Data frame. Then we'll take one first data frame equals to data frame. Eight. So we need to use the DT extension to take the time period in the month folder. So in this case, we are showing the revenue per month. And when we check on our data set, you can see there's no column called month. So you need to extract month from this date column. Okay. So dt dot to here we go. Then in this case, we'll note the month as M, which is in capital. So let's yes. Oh, I've used the accessor with can only use GT accessor with data. Okay, yeah, I've seen. So you first need to convert the date section to in a date time like values that you can use this dot dt extension accessor, sorry, not extension. So how will you do that? So you'll do d right swelling equals to pt to it. I think that's data frame. Okay. So we are first converting this column, the date column, to a date time like value. So this is how you convert it. You make it since you're referencing it as a data frame, you use the function dot to underscore date time. Then you reference which column you want to change into a date time. So let's see if it runs this time. Yeah, it's okay. So we'll proceed with creating the line plot. We'll just do monthly. And what we're doing here is we're looking for the sum. So we'll just use the sum. Yeah, that syntax is okay. So we have defined a new variable called monthly revenue. And in this case, monthly revenue will group this data as will group this data by the months by tallying the revenues in those months. So if a month had 30 days, it will find the sum of that revenue in that month, then group it as months. So the sum of January, then the sum of February, sum of March, so on and so forth. I hope we're good till there. Okay, so we'll head to the next step, so, which is now plotting. So PLT dot let's give a fixed size like 10 by 6. Okay, so PLT dot plot monthly right spelling, so revenue. This is not necessary, but since I want to extract the data as a string, so I'll just specify the how I want to extract the monthly revenue also. That will against monthly. I don't need to. Okay, I think at this point, I think I need to relocate. I'm experiencing a lot of problems with internet, then electricity. Okay, anyway, back to our session. So I hope you guys can see what I'm typing out. So yeah, that's the plot function. So the next function will run is the title, sorry. That is the title. Then we customize the X label. So in this case, we just take it as month. And now customize the Y label. In this case, it will be total. Let them do rotation. 2 degrees. But I don't think we'll need these codes. It's monthly and there are a couple of months. So anyway, let's just proceed with it. P, what? Do you want a grid? Let's just take it as just try and display it. See if and I think that's the issue here. Oh, I used the wrong marker here. That's yeah, now we're good. So as you can see, yeah, last time we were experiencing some issues where it was displaying this X axis on a daily revenue, not monthly revenue. So in this case, you'll first have to convert it into date time like value, and this is the syntax of converting it. Then after converting it, then you use this dot dt dot to period. Then in this case, you want to fetch the month, so it will fetch you write m, so which notes month. I hope you're good till there. Okay, so that is the first one. So we've solved it. The next one is create a bar chart displaying the average profit for each category. So let's see. Let's keep the right screen. Next one is calculating is creating a bar chart average profit for each category. So first thing we'll have to do is define the average profits. Yes. How do you find average profit? So in this case, you'll just sum the profits in each category. So average profit is, so we'll first have to group them by category, then find the sum of the profits. So in this case, you'll do df dot. Jesus Christ, what is wrong with me? Please bear with me for today, because I don't know what's up with this internet. So we'll group by category, then find the profit. That is the right syntax. So we grouped them by the categories, then found the mean of the profit values. So we'll just plot the figure. Let's give it a 6. Average profit. Oops, plot. So in this case, specify the kind of plotting you want. So in this case, you want a bar. And this is one of killing a rat. So the other one we talked about is dot bar. So, but let's use this since it will be. It's not a stacked, but it will be a graph. Not a graph, but a bar graph. So this is one way of doing it. You specify the kind, but use the dot plot extension. But you can use the dot bar. So we'll specify. Pick another color. Let's green. Maybe first one is red. Then maybe purple. Good. So now let's give it the title. In this case, it's average each check. Then customize the X label. The X axis is constant, so category. Then on the Y axis, give it average. So just, is there any need? No, there's no need of customizing the X ticks or the Y ticks. So just take empty show. Run it. So we can see this is how it looks. So what first things first, you've seen there is a way of creating a bar graph from dot plot. That was the main thing of using this method. Then you specified the colors that we want on these bar graphs. So since it's four categories, it will group them in A, B, C, D category. Okay, I've seen now the purpose of customizing the text. So let's customize BLT dot XTX brackets. So in this case, rotation, I want it to be yeah, no, it's good. So yeah, we've plotted the average profit for each category, which was question two, create a bar graph, a bar chart displaying the average profit for each category. So the third one will generate a scatter plot of value versus quantity. As we said, the scatter plot shows the relationship between two variables or two values. So we'll head to the next one. Now we're on the scatter plot. So first thing we'll do is just PLT figure size 10 by 6. Then scatter dot ELT dot scatter. Then in this case, we want to start a data frame value versus quantity. So we'll take df, then take value as the first data frame. Then plotting it against another data frame. So in this case, it will be df which is now quantity. Right way. So let's first leave that. Then we give it ELT dot title. So give it title. In this case, we're plotting value against and the next table value. Why label? Get the extension color bar to extend the color. So color bar. How we define the label? We have not defined. But let's first run it. I want to show you guys what error you would run. MPLT. This case has given us this scatter, but the condition here was generate a scatter plot versus colored by category. So you can see I've used the extension to color bar, scatter, then label by category, but there's nothing different. If we remove this, you'll see output is still the same. Okay, so what you do is you'll come here on the scatter, since this is the one that we defined right here on the color bar. So you'll just use the more. Let's see, color is equals to data frame. Then we'll map it. So you'll use dot map, then dot map, furthermore extend, then change the, so in this case, the categories are A, B, C, and D. So A will give it the code 0. A, then you give it one, but this one will give it 0. That is on A. Then you'll proceed to the next one. No, in case you want it to be A is a string. Then B, and B. So in this case, B will be 1. Then proceed to C, must specify it as string. C is equals to 2. Then the last category is B. It's going to be B. Yeah, so those are the categories. So you first convert them to the codes noted by the color map built-in function in Plotly. So yeah, that is, I think that's okay. Let's try. Yeah. So as you can see, the built-in map, the built-in map color map in plot in Matplotlib is it is known by codes. So it will note 0 as the code. So in this case, 0 is purple. Then 3 is this yellow. So The quantities that will fall in between those categories will be noted by that color. So when you try and match it, so you'll see the ones in between the range 2.5 to 3.0 are yellow in color. I hope we're clear till there. So the first thing you'll do is you define a new variable. And the reason of defining a new variable is you later on come right here to refer back to it. You'll have to refer. So in case you had not defined this, then you come here and write scatter. Scatter isn't a variable, it's a function in Matplotlib, right? So if you don't first define the scatter, then customize it, this this whole line of code right here will be irrelevant. I hope you're good till there. So we've tackled on the data visualization with Matplotlib. So the second section is data analysis with pandas. So calculate the total revenue and profit for each category. Okay, so just add a new line of code. So how I think let's yeah, we imported the already imported the pandas. So we'll just give it a variable name total underscore revenue. So here we are going to use the panda functions. So in this case, we'll have to use sum. So since we want to find the sum of each category. So is equals to so EF dot group by. We're grouping it by category. And we're going to find everything. Then profits. Then dot. Oh, since we've specified, since we have two data, two categories right in between this section, so we'll have to use the double square bracket. So I have to use that right there. Then it's right there. I think that is okay. So we'll just print this, see what will be the outcome. Funny. Found method group by sum of pandas. Found the methods. Huh. Then what library? Found method group by sum. Don't know, it's running some errors. Don't, let's first see the second question, then we'll come back to that. So determine the top 5 dates with the highest revenue. But I'll have a look at this just right after this. Let's see. We'll give it top 5 two here and origins brackets 5 then take set revenue, the column revenue data sets. Then we'll come here, take so we're taking the largest 5 of the revenue. So dates, more revenue. With that, we'll have to put it in the list. The top 5 list is actually okay. So let's print this out. Right. Underscore. Okay. So in this case, it has given us the largest 5 dates with the highest revenue. So in this case, it was this certain date, the 1st of March, 26th of January, 25th of March, 31st of January, and 24th of March. Yeah, so we've seen the top 5 dates with the highest revenue. So we'll find the correlation between values, quantities, and revenue. So let's see. So the correlation, just give it the variable name correlation. Since the extension is not correlation, so let's just use it. Data frame. So in this case, we are using 3 data frame, 3 columns, the value, the quantity, and revenue. So we'll just take that, since it's a list, just use the double square brackets. Then the first one will be value, then comma, then the second one will be then the third one will be part, then revenue. Now here's how you find the correlation. So how you find the correlation between different data sets is you use the dot or extension. So you print this. So the correlation between the 3 categories is value to value is 1, value to quantity is 0.07, value to revenue is negative 0.1. Then the quantity is 0.07, then quantity 1, then quantity to revenue is negative 0.06, then revenue to value is negative 0.01, revenue to quantity is negative 0.06, then revenue to revenue is 1. Yeah, and basically that's how you find correlation. So what you have to keep in mind is you use the extension dot correlation, then select the data set that you want to find the correlation in between. So let's check the next one. So we're done with pandas, but we're not really done, since I'll have a look at the first one. But yeah, so let's see the data manipulation with NumPy. So compute the moving average of the revenue over a 7-day window. So moving average of the revenue over a 7-day window. Okay. So in this case, take EF. Then we're defining a new data frame. So how do we find the moving average? So we just So we'll find it by go into the window 7 days. 7. And right here we'll just find them. Since simply the moving average is the mean revenue in a window of 7 days. So just have to use that mean. Good. It is think it will be a list. We'll take two sets of the square brackets. So the first one will be take date. That will be and the third set moving since we've already defined it. So moving uh yes. I think we're good. Well, I've seen the error right here. So in this case, since it's a data frame, I have to use sets of let's see the average moving. So you might ask yourself, so what's going on here? So the moving average, since we are using a window of 7, so it will calculate 7 dates or simply 7 rows. So you cannot find the average of 6 values when the dictated average should be 7 values. That's why when it displays right here, it will display not a number. So for the first 6 figures, it will display not a number. Then on the seventh one, it will calculate the average. I hope we're good till there. So that is simply the reason of using dot rolling. Then the window we specify we want a window of how many days. So if we wanted to take 3 days, you'll see the first 2 days will not be accounted since you can't find the average of 3 days from 2 days. I think that makes sense. Yeah. You cannot find the average of 3 days from 2 days. I hope we're good till here. Yeah, so that's computing the moving average of the revenue. So normalize the price column to arrange between 0 and 1. Okay. So let's add. Is there any question so far? Okay, let's proceed. So we're normalizing the price column to arrange between 0 and 1. So the first thing you'll have to do is create the data frame called normalized column. Let's price column, price. So in this case, we'll take, how do we find the normalized price? In this case, we'll take, set curly braces TF, then use this. So the first set is price, find the minimum of the price. Yeah, I think we're good till there. And close this. function, then divided by the data frame um, with this data frame price. Yeah. Yeah. Right. Use that one. So you've defined the first one. So let's close this. So we'll just print out this. So print. So in this case, we're taking data frame first. So do data frame. I think it's the list of data frames. So do price. Price, yeah, price against these. I think that is okay. So let's run it. So the condition was normalize the price column to a range, yeah, between 0 and 1. Yeah. So you can see right here when you check all the prices, when you check the normalized prices, you'll find it is in between the range that is specified. And how do you find that? So you find the minimum of the price divided by the maximum of the price. So technically, maths states that the minimum divided by maximum will be less than 1. So it will be 0 point something. I hope you're good till there. So yeah, that's basically it. I think we are done with the assignment apart from this question. Let me check it again. I'll have to check this out later. But yeah, I think we're good till there. So yeah, that is how you are supposed to do handle it. It's quite confusing, but yeah, with practice you'll become so good at it. So we'll have a look at what we're supposed to look at today. So today's topic is Plotly. Plotly is it'll be so fast since we've already tackled Matplotlib, and it's almost similar to it, but a better version. But it's simply a library that is used to plot, as the name states, Plotly. So we can see on the table of contents. So the first thing we'll have to look at is Plotly Express, then define it, then find the difference between Plotly Express versus Plotly graph and objects. So we'll see the basic plot types. So the only new plot type we'll discuss right here is violin plots, which is simply a better version of box plot since it is used to predict mostly the violin plots. So we'll have a look at customizing the Plotly Express. This we had already handled this with Matplotlib, so it'll be so easy for you guys. So facetting and subplots. So I think we had discussed what facetting is. It is similar to subplots, but facetting is the mini axes share one. I don't want to call them mini axes since they are not mini axes, but they're in one figure, and they are tiny representation of certain data, constant data. So you can find some data is being shared between one section, one facet to another facet to another facet. Yeah, that is simply what facetting is. It's simply creating, it's just like a subplot. So then we won't this is what will be today's assignment. I won't tackle on exporting and sharing plots with pyplots. So I want you guys to go and research. So I'll give you a hint. we don't use the libraries that were used some time ago are not the ones that are used nowadays to export the plots as image. So right now we use Orca, and Orca is it's simply a library. So today's assignment, after tackling all this, your assignment today won't be this based on the curriculum. It will be this exporting and sharing plots. So I'll give you maybe some data that is already defined. Then you you guys will send it to me as a PNG and also as a HTML file. I hope we go till there. So the first thing we've said, Plotly Express is a high-level interface for creating interactive and visually appealing plots using the Plotly library. With just a few lines of code, you can create complex visualizations that are easily customizable and highly interactive. So Plotly is designed for ease of use and efficiency, making it popular choice for data visualization tasks. So with omitting all this explanation, simply it's a library that is used for data visualization, but the complex data visualization. So the other difference we'll have to look at is the difference between the express and graph object. So while Plotly Express provides a high-level simplified interface for creating plots, Plotly.graph object offers a more flexible, lower-level interface. So simply the difference between these two is this one is used by somebody who is very who has very good knowledge of Plotly, and Express, we use very few lines of code to visualize the data. So when you use the .graph objects, you use a lot of lines of code so that you can visualize something. But simply this is used for people who are very conversant with the Plotly library. So the first thing you'll have to do is install Plotly. So um, yeah. So the first thing you'll have to do is install it. So pip install Plotly. Then run it. Installing it in the background, and since I have bad internet, it will take some time. So why? Wow, I have really bad internet. So it's still installing. Why is my internet so disappointing? Wow. Yeah. So it has now installed Plotly. So the next step, as you can see here, is importing the necessary library. So in the case of Matplotlib, we're using the pyplot. So in this case, it's Express. So you'll have to just input it as the way it is. So import. So in Pyplot, we use the extension PLT. So in this case, we'll use PX for the Express as PX. Then run it. It's okay. So we've installed and imported the necessary libraries. So the next, so what we'll have a look at now the plot types. So the scatter plots, the bar, the pie, the violin, the box plots. So that will be so quick. So we'll start with scatter plots. So we'll just copy this line of code and I'll tell you what this simply does. So here we've defined the data, and you're probably wondering, where is this data? So in Express or Plotly, there are already defined data sets. So in this case, we'll use Iris. So Iris is a data set that is already installed in the libraries. That is, it's a built-in data set in Plotly. So actually, let me show you guys how it looks before even running this. So let's first cut this. Pass it into a data frame. Df. Yeah. So let's print the head. So this is the built-in data set called Iris. So it has the column sepal length, sepal width, petal width, species, and the special ID. So we'll use that data. Not even eliminating it. Let's just leave it at that so that I can explain it better. So this is the data that we'll reference right down here. So we have defined the data and we've used the built-in dataset.iris. So in this case, the figure is equals to px, which is the notation for Plotly Express dot scatter. So the way we are using dot plot dot bar. So in this case, we'll use dot scatter. Then reference this data. So what data do you want to scatter? So this is the data. Let's call it. Okay, let's just call it data. So that's the data you're referencing. That's the data. That's the variable name. So in this case, you're probably wondering, what is this syntax? So x on the x axis, it will be sepal width. So it will take these dimensions. You see on the sepal width. So it is simply telling the plotly.express that on x we want to take the column width. So here we deal with specifying the column width, not width, but the column names, column labels. So we've stated that we wanted to the sepal width to be the reference on the x-axis. On the y, it will be sepal length. So x is sepal length, y is sepal length. Then color, we want it to extract the color from the column species. So it will extract the color from this column. Then the title is scatter plots of iris data. Then we know what this does. Fig.show is it shows the figure. So when we run this, you can see it has it has defined it. So on the x-axis is the sepal width, on the y-axis is the sepal length, and you're probably wondering. So the good thing with Plotly is, in Matplotlib, the way we are defining legends. So here we don't. Okay, we can customize the legend, but we don't define the legend. So that's a very good feature of using Plotly.express instead of Matplotlib. So you can see this is the legend right here. It has given us species. So the purple ones will be Setosa. The red ones will be Versicolor, and the green one will be Vigenica. I think we're good till there. So that's simply how you plot the scatter. You use the dot scatter function, then reference the data that you want to scatter, then define on the x-axis what you want, on the y-axis what you want, then the color what you want. So I think we're good till there. Okay, so that's the scatter plots. So line plots, let's just copy this. So this is another built-in data set. So the first one we've seen Iris. Iris is the built-in data set. So Plotly has a lot of data sets that are built in. So this second data set is dot stocks. So we are plotting a line. So figure is equals to px dot line. Then we reference to the data. So in this case, this is the data. Then the same way we've seen here that on x-axis it's giving us sample width and y-axis is sample length. The same thing applies here. So actually, before running this, I want to do what we have done previously. So we just take df, then df dot. It has given us, so this is the data frame. These are the columns: date, Google, APL, Amazon, Facebook, Netflix, and Microsoft. So now we want to plot the line plot. Just we want to interfere with that. So in this case, we want to plot the line plot. So the data is the referenced data set. Then on the axis, we want the date. And on the y-axis, we want the Google data. So in this case, it will fetch these values that you can see right here. And the title will be Google stock prices. Then figure out show, when we run this, so this is how the graph looks like. The line graph, the line plot. So it has followed what we've dictated. So on the x-axis, we wanted the dates. Then on the y-axis, we wanted the Google. I think we're good till there. Okay, so the next one will be bar plots. You see, the way I told you guys, like it will be so quick today since you guys are familiar with the concept, right? It's just change of syntax. Just add a new line of code. So in this case, it's a new data set called tips. So let's display it first. But so this is another built-in data set. So we have seen now three data sets: the stocks, and iris, and now tips. So these are the columns in tips. So total bill, tip, sex, mocha, day, time, size. Just take all of it and paste. So in this case, we are creating a background. So we're using the extension.bar. So we are referencing to the data. So on the x-axis, we want it to be day. On the y-axis, we want it to be total bill. So the color is defined from this column right here. So it will define the colors based on sex. So if let's assume it dictates that it wants female to be green, female all the female will be green, and let's say it said male to be red, all the males will be red. You see the way Plotly is making work easier. So the total will be total bill by day and gender. So when we run this is how it looks like. So you see the legend here is stating the blue one is female, the red one is male. I hope you're good till there. So yeah, that's the bar plots. So histograms. So histograms, we said it is used to show the distribution of two values. So we'll just copy this. So in this case, we're using the same built-in dataset tips. So figure is equals to px.histogram. Then we're referencing back to data. Then on the x-axis, we want it to be total bill. Then the number of bins, we want them to be 20. So I think we had discussed n bins in Matplotlib. So number of bins, we want them to be 20. Then the title, we want it to be histograms. So let's run this. So this is how our histogram looks like. it was necessary, but since the beans are not yet 20, it means the data was the data extinct on 11 counts on 11 beans. So yeah, this is this is this is a huge number, but we'll just take it. So yeah, that's simply how you create a histogram. Is there any question so far? Okay. So the next one will be box plot. So we said the box plot shows the distribution of a value based on certain things like the first quartile, third quartile, median, maximum, and minimum. So we'll just take this. What is the main difference between matplotlib and plotly? Okay, simply there is not a really big difference. The difference is like most I don't want to call them institutions, but most companies, some companies prefer their data represented in Plotly or Matplotlib. So as a data scientist, you'll find most of the scientists preferring Plotly over Matplotlib. Matplotlib is past its time. It's not keeping up with the trends right now. So as you can see, this is making our work so easy. We don't have to keep on defining the legends or the labels, then declaring the legends in Plotly. Yeah, that's simply the difference between the two. So later on, you'll see you won't prefer Matplotlib at all. You'll later on when you want to plot the data, you'll just be using Plotly. But there is no difference apart from the syntax and preference. Since what Plotly can do, Matplotlib can do, same thing applies to each other. I hope I have answered your question. Yeah. So simply it's the ease of use. Plotly is easier to use since it has built-in so many built-in functions. So the box plots, just copy it at this. So data is equals to px.data.tips. We're using that data set, the built-in data set. So in this case, we've defined the figure as px.box, then reference to this data right here. Then on the x-axis, we want day, y-axis, we want total bill. Then we want it to distinguish the color based on sex. Then title is this. So when we run this, my internet is so bad. About that I had gone to check I don't know what's up with this internet. So yeah, this is basically it on the box plots. So we'll tackle the next subsection. Oh, without even. So let's see. I hope you guys can hear me. Jesus. Yeah. I think you guys can you guys hear me? Okay. So we'll proceed. So the another good thing about Plotly, when you hover on it, you see it is giving you a detailed explanation. Yeah. That is the magic behind Plotly. It's so good. It's giving you this is the figure at max. this is the upper fence, this is the quartile, this is the medium, this is the Q1. You see, that is the good thing about it. So that is box plots for you. So violin plot is the next thing. So you're probably wondering what is violin plot and what is it used for? So it uses the technology. This is the technology right here, KDE, kernel density estimation. So most cases we use this we use violins to display probability. So the how will you use a violin? So let's say you're working for a hospital and you want to see if this number of patients will have recovered after okay, how many days will it take a certain patient to recover if they have gone the same surgery? So that is what we call kernel distribution estimate. So density, sorry, not distribution, kernel density estimate. So that is where you use violin. So it will display the most common point where patients were recovering from. And you'll simply detect outliers in the data set. So let's run it. So as you can see, this is the violin plot of total bill by day. So let's see. So you see when we hover, you can see the KDE. So where KDE will be marks right here. This is the max KDE. So where it is max is where the total bill is most likely to be. So in this case, it will be 17. On Saturdays, it has analyzed the data and it has seen the kernel the density estimation on Saturdays will fall into 17.3391. I think we're good till there. Same thing applies to these other sets. So on Thursday, the KDE, where is it? Mark, so it's right here. So on Thursday, the total bill will most likely be 12.76282. Yeah. So that is violin plot. So pipe plots. So in this case, it's data is equals to px dot. So let this syntax not worry you right now, but it's simply querying a certain section of data. So in this case, it's querying where the year is strictly 2007 from a data set called Gapminder. So the how do you create a pipeline? So can you guys hear me? Wow. I think maybe I was thinking we were on the same page, but where's the last point you guys had me? Where was the last statement that you guys had? Had we tackled the pipelots or were we still on this? I don't want you guys to miss anything. So can you help me on that?
You are talking about the KD.
Okay, that was the last point. Oh,
Yeah.
sorry about the internet. Okay, so I was saying the kernel the density estimation it is simply used to predict. That is where you as a data scientist, when you plot the violin plot, and I think I've given you guys the case scenario where in case you had hospital data, then you wanted to know how after how many days will this certain patient recover based on past data. So you'll detect outliers from this violin plot. So you'll just see right here. So you'll just have to check the max KDE. In this case, it's 0.508. So the most probable total bill on Sunday will be 17.74. So that is the most likely total bill on Sundays. Same thing to Saturdays, you'll just have to check where the KDE is marked. So it's 507. So on Saturday, the most probable total bill will be 16.5028. I think we're good till there. Okay. So so the next thing I was talking about is pipe load. So don't worry about this syntax right here, since let me copy it. It's already here. So don't worry about this fast syntax. So it's simply extracting data from a data set called Gapminder, and it's querying a subsection of that data. Since probably this data is so huge, so it's querying strictly where the year was 2007. So we don't want the 2008, 2009, since maybe the data set is quite huge. So you query the data set, then uh, uh, strictly dictate that you want to query the where the year was 2007. So when you want to plot a pie plot, this is the syntax. So we're creating a figure. Fig is equals to px.py. Then we're referencing to this data set. So values will be based on pops. Then the names. Okay, let me first show you guys what it looks like. Let's put this into a data frame. So df10. So yeah, this is how the data looks before even plotting it. So when you specify it's simply the same with bars and lines and scatter plots. You'll simply state what you want. So in terms of the pie chart, you'll use the value as the desired column. So in this case, you can use life expectancy, pop, GDP, yeah, isonum, which is ISO number. So yeah, that is simply it. Only. Okay. Right here. So in this case, we want to create a pie chart from this data. Then the values will be pop. So this will be the values inside the pie chart. Then the names will be based on continents. Then the title will be population by continent in 2007. So what you have to know is values is the how you declare what you want in that pie chart. So in this case, the values will be pop. So let's run it. See what will be the outcome. So it has checked the values. So this is let's. So this is the general. This is yeah. Okay. So it has added all the continents percentages, then distributed it in a pie chart. So on the continent of Asia, the pop was 3.8 billion. So that's the population. Um, in Africa, it's 929, 898 on Americas, 586 on Europe. Then Oceania is 24,549,000. So I think you guys can see the advantage of using Plotly. Because before, okay, even in Plotly, when you use the .graph underscore objects, so the graph objects, you'll have to write a lot of code so that you can have an output that is similar to this. I don't know if you guys are conversant with other like maybe coding. So in terms of like CSS, there are things like Bootstrap and Tailwind. So those are the frameworks in CSS which help you in the front end web development. So in this case, Plotly helps is like a framework in this in plotting all these kinds of visual data. So it is simply easier to use. Yeah, you can you guys hear me? I need to keep on checking with you since I have no faith with my internet. Can you guys hear me? Okay. So you guys can hear me. So let's proceed. So let's head to the next thing, which is customizing plots with Plotly Express. So in this case, we'll customize the markers, the lines, the bars. So let's just paste this, then let me explain. In this case, we're using the Iris dataset, which we had used it up there. So the next, so we'll create a scatter plot. So fig equals to px scatter. We've already discussed about what this does. Then referenced back to data. I think everything here is quite you guys know what it means. So what you don't know is maybe from here. So you can also add up the size. Size will be based on petal length. Then the symbol will be based on the column, species. Then the opacity will be 0.7, so it will be a bit transparent. Then the text will be displayed based on the species. So on every scatter plot, we'll see that there'll be a text on each marker. So yeah, that is simply an extension of customizing the scatter plot over there. So then there is fig.update underscore traces. So this is used to update the defined changes. So in this case, we want to have to change the marker. So the marker is equals to dict. Dict means dictionary, which is funny. So what dictionary is simply we have a wide variety of customization on the marker. So we state that it's a dictionary. So marker equals to, since it has extra things, you use dictionary. So dictionary, then we furthermore customize inside the marker. We want to customize the line. So the line is the border of that marker. And since it's also a dictionary, since we can customize the width, the length, the color, yeah, the edges. So it's also a dictionary. So you use equals to dict. Then we now come to the concluding part, which is now width equals to 1, then color is equals to black, then fig.show. I think we're good till there. I hope I've explained it in a way you guys have understood. So as you can see, as I've said, when you check this right here, we have stated that the text will be based on species. So this is not quite pleasing, but since we already have this legend right here, which tells us the blue or purple is Setosa, the red is Versicolor, the green is Vigenica. So I don't think we really need this, but yeah, that is simply how we use it. So you can see, I think this is a bit better. Yeah, I think this is a bit better than the other one. So yeah, that is simply how you customize it. So this is the built-in function of updating the traces. So dot update traces. So we'll head to the next thing. I think you guys can see here. Yeah. So changing colors and color scale. So let me just copy this, but so in this case, it's a histogram. So we're using the tips data set. So fig is equals to px.histogram, which is expression for creating a histogram, then referencing it to the data that we want to create a histogram for. Then x, we want it to be total bill, the number of bins to be 20, the total to be histogram of total bill amounts. Then we have furthermore gone to color. Color will be based on sex. So if there are two genders, let's say female and male, it will have two, two varying colors. It will kind of look like a stacked bar graph. So it will start with the least one. Let's say that it's female. So the female will be noted by blue. Then let's say it chooses male to be green, it will note it by green. So the color discrete sequence. So this is simply customizing this color equals sex more. You're simply customizing it to your liking. Let me show you guys what I'm talking about. So let me first omit this, then run it. So you can see it has chosen its colors. So this is it has its own mind of telling it like you choose just any color for noting the gender. So as you can see, this is the blue one is female, the red one is male. So when we furthermore want to customize it to our liking, use the color sequence. So this is the how you customize it further. So you use this built-in syntax or function color underscore discrete underscore sequence. Then since it's a list of different colors, you use the square brackets. Then specify the colors that you want. So we want the first the females to be dark blue and the males to be hot pink. So let's run it and see if we see the difference. So you guys can see the difference, right? So that is simply how you customize the colors in histograms or in pipelines. Just use the color sequence, color underscore discrete underscore sequence, dark blue or pink. So another question you might be asking yourself, what if we ignore this? So let's see what it does. Let's say we just use the color discrete sequence without dictating the color. So you'll see if you don't if you don't give it directions on what to base the color or on, it'll just give it'll just give you the colors based off one or of the first declaration. So you'll take dark blue as the first one. So in case we had used hot pink, the first one, then run it, you'll see it'll just take the first declaration. I hope you guys have seen the importance of first declaring the color where you want it to be based off. Let's take that comment, add it here. So that when you now run it, it follows the sequence based off sex. Yeah. So I think we're good till there. So that is changing colors in color scales. So modifying the axes and axis labels and ticks. So let's just copy this and let me explain what it does. So in this case, we're using this data, and it's from the inbuilt dataset stocks. So fig equals to px.line, then we're referencing it to the data, this data right here. Then on the x-axis, we want it to be date, y to be Google. Then the title will be Google stock prices. So when you want to update the axis, you don't update it directly. So let's assume you wanted to, you just, let's take this, run this. So this is the original. This was the original look. So let's say you wanted to change the axis. So you'll just use the update axis function. So if you want to update the x-axis, you use update underscore x-axis, then give it the title that you want. So the first one was dates with a small d. Yeah, dates. Then the ticks on this case were rotation. The rotation was 0. So the ticks was 0. So we want the new tick angle to be -45. So it will be slanting. Then show grid equals false. So the default show grid boolean is true. So you can see here, even if we had not dictated earlier, it was there. So when we run this, you'll see, let me first make this y-axis. Sure. So when we run this, I think you guys can see the difference. The date has changed to what we wanted, which was date with a capital D. Then the ticks have slanted to a negative 45-degree angle. Yeah. So now let's update the Y. So in this case, we want to change it from what was the default one? So it's Boog. So we want to change it from Google to rice. Then grid color, we want it to be gray. So in this case, you're customizing the grid individually. So on the y-axis, these are the grids. What you guys can see, those are the grids. On the x-axis, since we stated false, we can't see them. So in case we had not dictated that boolean, you can see it's true. So you can see there are lines. They are horizontal and vertical lines. So I think we're good till there. So that's simply modifying axis labels and ticks. So updating legend properties. So we have seen that Plotly is helping us with the legends. We don't have to keep on declaring legends. But at times, maybe you don't want the legend to be there, or you don't want those colors to be those colors. So this is how you do it. Let me copy this and explain the syntax. So in this case, our data is equals to px.data.tip. So we have used the tips dataset. So this is in this case it's a bar graph. So x-axis we want it to be day, on the y-axis we want it to be deal, and the color we want it to be based off sex. So it will be a stacked, yeah, it will be a stacked bar graph. So the title is total bill by day and gender. So how do you update the legend? So we have seen when you want to update the markers, we use update underscore traces. So when you want to update the legend, you use update underscore layout, since legend is part of the layouts, right? So legend equals to dict, which simply means dictionary. And the reason we're using dictionary is because we can customize the legend with so many things, which in this case you can see them. So the first one is title. You can give it the title that you want. So we've customized it to give it the title gender. Actually, let me first cancel this. Now you can see the default one. Let's first run it without even specifying the things. So this is how the chart looks, and this is how the legend looks. So let's focus on more on the legend. So you can see the layout is in a horizontal way. Then the title is sex, and blue is female, then red is male. So let's paste it. So the first one is title. So in our default one, the title was sex. So we wanted it to change it from sex to gender. Then the orientation. Orientation is simply the layout style. So H is horizontal. Then V is vertical. So let's just use H. Y anchor is where do you want it to be based on of the Y axis. So we want it to be at the bottom. So this is the this is the Y axis. The y-axis. So we want it to be bottom. So in this case, it's top. So y anchor, I want it to be bottom. Then we want it to be displayed on the section on y, where it's 1.02. Then on the x-axis, we want it to be displayed on the right side, which is already there. Then on the x-axis, we want it to be displayed where it is 1. So when we run this, see, so it has changed the layout, gender, then it has given it it has changed the title, gender, then given us the layout horizontal. So, yeah, that is simply how you customize the legends. Any question? Uh, well, is there any question? Okay, so let's proceed. So setting plot titles and subtitles. So this is quite easy. So we'll just copy this, paste it right here. So data is equal to px.data.type. So that is the data set that we want to create a box plot. So on the x-axis, we want day, y-axis, we want total bill, color, we want it to be based off sex, then title to be this. So since we want to customize the titles and subtitles, that is part of the layout. So you'll use dot update underscore layout. That is the same thing with legend. So in this case, we want to customize the title. So the first one will be title equals to dict. So since we are customizing a couple of things, so title is equals to dictionary then equals. So the first thing we want to customize is text. So this was the first text. Box plot of total bill by day and gender. Let's change it. The let's say the first one was day and run. Yes, you can see that is the title. This is how it looks without even customizing. So when we paste ours, so the text will change from day and sex to day and gender, where X is 0.5. X anchor will be center, so it will move from the left to here, right here. Then the fonts want to be size 24. And you can also furthermore change the fonts to sans serif, Montserrat, the ones that you want. So Arial bold. So that is the title. So now customizing on the subtitle, which is simply denoted by annotations, is annotations is equal to dictionary. Then text, we want it to be subtitle distribution of total bill amounts, where X is 0.5, where Y is 0.95. X anchor to be center, Y anchor to be bottom, so it won't be up here, it will be at the bottom. Then show arrow equals to false. So the reason we are furthermore declaring it to be false is when we use the default one, which is true, when we don't declare it that way, it won't follow what we want right here. It won't follow most of the time. So since the arrow will push the text maybe up, that is the reason you have to dictate the show arrow equals to false. Then the font, we have dictated it to be size 14. So when we run this, so have a look at it. So right now we've not defined the show arrow to be false. So it is default true. So when we run it, so it has followed the first one. The box plot has come to the center of the figure, and it has changed the text, day and gender. Then, as you can see right here, this has not followed it. Since on the X, we said it to be on the X anchor to be center and the Y anchor to be bottom. Is it really at the bottom? Not really. So when you declare this, show arrow equals to false. Now let's run it and see change. So as you can see right now, it has followed the Y axis. So initially it was somewhere here. Now on the Y anchor, it is now at the bottom. I think now you have seen the reason of why we declare the show arrow equals to false. I hope you're good till there. Okay. So for setting in subplots with Plotly, see if this. Okay, so this is our last subsection. So for setting, as I have said, is simply it's just tiny like subplots. So let me use actual data so you guys can see what I'm talking about. In this case, we want to create a scatter plot based off x-axis to be total bill and the y-axis to be tip. So the facet here, right here, is day. So we want to compare day and time. I hope you guys have understood what it simply means. We want to create a scatter plot where the x-axis is total bill, the y-axis is tip, but the facet, so the mini subplots will be comparing these two things, total bill and tip, based off the day and based off the time. So on the column, it will be day, on the rows, it will be time. So let's run it. So you guys can see the mini plots. So generally, this is the tips, which on the main scatter plot is what we said. Y to be tips and X to be total bills. So then on the facet column, so on the columns, we stated that we wanted it to be day. So just give me a minute. Sorry about that. So let's have a look at it. So we stated that on the columns we wanted to be day. So these are the columns. So it has followed that rule. And on the rows we have stated, we state here. So on the rows we want it to be time. So it is dinner right here. So on the rows it is stating that this is dinner. The second row is lunch. So there are two rows. I think you guys have seen what faceting is. Okay. So creating subplots using the function make underscore subplots. So this you'll have to import different libraries. So I'll just copy it from the top. So we'll import our plotly.subplots as sp. Then we'll import the graph underscore objects. So we won't state objects ahead of objs as go. Then plotly.express. So this one we had already imported. Fine. So let's first import those libraries. I think we're good. So here we want to take this data and then we want to create the subplot. So you'll have to, since we have imported the plotly.subplots and stated it to have the notation sp. So fig equals to sp dot make underscore subplot. So we have seen right here on our curriculum that that is how you make subplots. Make underscore subplots. So then you can define more on the number of rows that you want in the subplot. So I don't want to use this for set since they're a bit different things, but simply when you declaring rows right here, it will be rows to be 2. So in this case, the rows are 2 and columns to be 1. So, but on this case, columns are 1, 2, 3, 4. So that is simply what is stated right here. Then shared x-axis to be true. So on the x-axis, everything will be common. Then subplot underscore titles, we want it to be APL on the x-axis and APL stock prices on the x. Then Google stock prices to be on the y. Then we have seen update trace. So when you don't have a trace that is existing and you want to add it, you use add trace. Since this is something that is non-existent. So we'll use go.scatter. And the only reason we're using this plotly.graph of JS is because we want you guys to see where it is used, but this is not necessary. So, but we'll have to discuss it, but it's rarely used. So you'll add the trace, then the function here is you're telling the graph object to create a scatter plot. So on the x-axis, we want to declare it data. Then on that x-axis, we want to use the date. You see how bad it is? It is so definitive. You have to define a lot of things. So on the y-axis, we want it to extract data from Apple, then the name to be Apple. Then the line, we have to furthermore explain. That's why I hate it. I don't like graph objects. So on the line, we have to declare, we want to customize it. So I will take the color blue. Then rows on this scatter plot will be one row, or we not one row, but on the first, it will be on the first row and the first column. That's another flow of it. So you'll have to define this even more. Same thing to applies to this. So you're creating the second scatter subplot based off. Now the thing that is changing here is Google. The color is red. Now, in this case, it will appear on the second row, on the first column. Then now you update the layout with the title stock prices for AAPL and Google. So when you run this, it has given us two subplots. We had discussed this as axis and matplotlib. So in this case, it's a subplot. So it has given us the legend. Yeah, that is simply how you use it. So the reason, the main concept here was to understand the subplots, not all this syntax right here. But yeah, it's good to know the graph objects, where to use them and how they work. But it's quite long, so I don't think you guys will prefer. Is there any of you who has seen the syntax and said, yeah, I really want to use this? This is so long. And so okay, the it gives you freedom of editing and freedom of declaring, but it gets to a point where you're like, do I really need that freedom the way I'm given? So the main difference between the two is that on Express, you it gives you the initial one, then you say, I don't want this, then you update and change. So on Graph, it's you're the person who's responsible for declaring what you want. If you want the line to be blue, you'll have to tell it you want the line to be blue. So in this instance, let's just take this and omit it. See, and see, where is it? Where is it? Where is it? No, wait. Just that. Kindly you'll share the lesson from there's a concept I think it will as I go through. Okay, is it not on the Dex virtual platform? Hamza. Okay, if it is not on the Dex virtual platform, I'm really sorry. I'm really sorry about that. I'll update it, but I think it's there. But okay, I'll have a check. I'll have a check at it. I'll have a look at it. The most recent. Uh, I think we tackled it in one lesson. So yeah, but I'll have a look at it and maybe send it to you guys. Okay, we were checking, we were having a look at something. Let's just move this and paste it again. And in this case, yeah, I think we could. Oh, this time around it has been a bit better. So it has given us the blue line, but it's, yeah, at least this time it's done a good job. So the next thing we'll have a look at it. Created the subplots. So combining different plot types in a single figure. So this is the last section. So we'll just copy this. And paste it. Let me explain this syntax. So we have extracted it from the tips inbuilt dataset. Then we have created subplots. So in this case, it will be one row, two columns. The subplot titles will be box plot and violin plot. So we have to, since we have not created the box plot or the violin plot, so we'll have to add it, not update it, but add it. So add trace, then use the go.box for creating the box plot. Then we define it, y data we want it to be, total bill, x data we want it to be, data. Then the name to be box plot and box points to be outliers. Marker, we have dictated it to be blue, and we want this subplot to appear on the first row, first column. On the second one, we want to add the violin plot, so add trace. So go dot violin, then y data. Y, we want it to be total bills. X, the data on X to be days, the name to be violin plot, box underscore visible true. So this is the default one. So we don't have to declare it. Then the line color to be red. And we want this subplot to appear on the first row, second column. Then update the layout title, total bill distribution by day. So when we run this, it's given us two subplots in one figure, which I think that was what we were doing default. So the only difference is that we were using different rows. So let's see. Well, so this is the same. This is the same thing. It appears on the figure. So if we change this, for one column. One. So the same thing has appeared the same way. I think you guys can see. So don't worry. So yeah, we had already tackled it. So there's nothing new right here on making it an act. So it's just the difference is just declaring the position of the subplot. So in this case, we want it to be on the first row of the second column. So here, this is the syntax of declaring the number of rows or columns in the figure. Then here is declaring the position of the subplot in the figure. I hope we're good till there. Yeah, so what I want you guys to do is I'll send you like a simple data set. Then I want you guys to convert it into a PNG format and HTML format and send it to me. Okay, I won't tell you guys to send it to me via Airtable, since most of your drives are private and I have to ask for access. So I don't know if you'll just send me the HTML URL, then the PNG picture. Are we good till there? Okay, so I think we'll call it a day from there. So that's today's assignment. Simply converting these data sets to PNGs and HTML. Is there any question? Yeah, that is the last section. Exporting and sharing plots. Is there any question? So, well, if there is none, I think we can adjourn this class. Well, yeah, have a good evening. I'll send you guys the data set that I want you guys to convert into HTML or and a PNG. So, yeah, then we meet tomorrow. Today has been so, I don't know, the past 1 week has been so bad in terms of electricity and internet, but let's hope for the best. So, yeah, you guys have a good evening or afternoon, depending on your time zone. And let's meet tomorrow, same time, same place.